today with our joke of the day because I figured it's not as fun at the end. So here's our joke. How do mathematicians eat ice cream? In a cone. Alright, so we're going to be studying cones today and pyramids. So I thought if I waited to the end, you would just be sick of them. So anyway, hang in there. We're going to start our lesson. We are ready to start section 3 of chapter 12. We are going to be looking at the surface area of pyramids and cones. Now you can see again there are things they do have in common. They both come up to a point. They do have one base. Pyramids are going to have some kind of polygon. This time we have a square. It might be a triangle, might be a hexagon. Cone is always going to be a circle. So there are similarities and differences. Again, the pyramid always has triangles, where the cone is a nice smooth surface around here. So there are some differences. The formula for finding the surface area is similar, but different enough that that's different. I believe that this is the most difficult section of this chapter, so kind of bear with me, take good notes, go through the examples, and give everything a try. We're going to spend, that's why I have an extra day kind of going over, reviewing sections 1 through 3 before we have our quiz. So no new material tomorrow, but take a look at it really good, work them out. They don't always give you the parts you need. You might have to do some figuring, so that's what makes it a little more difficult. Okay, so we're going to start with the pyramid, and I'm going to draw one up here, and let's see how we take this apart. Okay, we are back to look at pyramids. I drew a regular pyramid up here, actually a square pyramid because the bottom is regular. We are going to really only focus on regular pyramids, meaning that our base is regular square, a regular triangle, regular hexagon, because otherwise all of our triangles would be different. So we're just going to focus on the regular figures, and that way all of our triangles around the outside will be congruent, and that'll make things a little bit easier for now. So the surface area, again, we're finding the area of all the faces. I wanted to point out a couple of differences on the pyramid. Now we have one base, again we talked about that before. The faces, all the triangles around the outside, are called the lateral faces, and they're going to ask you first to find the lateral faces rather than the whole thing. They may just start out with what's one lateral face. So there's one triangle would be one lateral face. This is a square, so we're going to have 4 triangles. So if they say find the lateral area, or the area of the lateral faces, you're going to find all of the triangles. Okay. Now what I wanted to point out is the difference in the pyramid is that we now have 2 heights we have to deal with. Okay. So let's look at a 3-dimensional square pyramid here. It's not too tall, but if you look at when we're finding the area of a triangle, notice that the height of that triangle runs along the side of the pyramid. Okay, so we can't call that the height, because the height of the pyramid itself would start at the vertex of the top and drop straight down and hit the center of the base. That's the actual height of the pyramid. So that's not the number that we need. We need to find, we use the cursive letter L to stand for the slant height. Now I tried to draw it in here, but I was hoping you could see better 3-dimensionally. So the slant height runs along the center of one of the triangles from the vertex to the edge here. Call it L. And hopefully you can see in here, if you could see inside my pyramid, drop from the vertex straight down perpendicular to the base. Okay, so here's our first question. They're saying, can we find one lateral face or one triangle of this pyramid? Okay, we're trying to find the area of it. So again, we're looking at just the triangle here, and we need to find L to find the area of our triangle using 1/2 base times height. And the only number they give us, though, is that it has a base 10. The length of the bases are 10. So they're not giving us that slant height. So here's what I need you to kind of C. Three-dimensionally, picture this out here, okay? So if we have the height of my triangle dropping down here, and they have the slant height here, we actually have a triangle. I'm turning the pyramid sideways, so we're looking through it. Here's my height of my triangle straight down. This is along the side of the base, and we actually have a little right triangle where this is my height, this is L, and this is the distance from here to here along the bottom, along the base. So from the center over, that means I'm actually cutting the distance across the base. We're going to cut it in half. So since it's 10 across, that makes this 5. So the question then is, can we find L? And I don't remember if they gave me an H or not, or if we need to do some, yes they did. They give us that the height is 12. So in this problem we know the height from the vertex to the base is 12, and we know the length of the sides are 10. So this gives us two numbers, meaning we can use the Pythagorean theorem to find L, and that's usually how they're going to have you do it. They're not pulling a whole lot of trig on top of what we're doing. Can't say it'll never happen, but most likely they're gonna give you two of the numbers. All right, so we're gonna find L, meaning we're gonna set up. We know 12 squared plus 5 squared equals L squared. We get 144 plus 25 equals L squared. And then you add this together, we're going to get 169 L squared, and therefore my slant height L, when we take the square root of both sides, L is going to equal 13. If you had recognized that we have a 5, 12, 13 triangle, you might have jumped right to there, but if not, Pythagorean theorem always works. So now we know L is 13. So I'm going to find the area of one lateral face, one of my triangles. We go back to 1/2 base times height. Now, if we're going to change that, since we're using not H, we're using L, we can change it to that. So it kind of keeps that in your brain, and that's going to help us when we do the formula of the whole thing. So let's switch height to the slant height. And then we have 1/2, our base is 10 along our triangle. The lateral or slant height is 13. So we wind up with 130 divided by 2, which gives us what? 65. 65. And that is the area of my triangle or my lateral face. Okay? Okay, now we're going to look at finding the whole surface area of a pyramid. I have a different pyramid here. This is a triangular pyramid. The base is a triangle. You may remember this from our Platonic solids. It's also a tetrahedron. Lots of names sometimes. All right, so we're looking at a triangular pyramid. I wanted to do was open it up for you. Hopefully I brought my scissors here. Okay, so we're going to make a net like we did with our prisms and put it up here on the board and kind of just see what it looks like. So anytime you open up a pyramid, we're going to kind of open the sides here. Hopefully. All right, and the base is going to be in the center. Hopefully this sees pretty good. All right, so here's my base, and the triangles open up, kind of open up around it there. As the base gets more intricate, a hexagon, it will open up to kind of look like a star, which is kind of cool. Okay, but this one you'll see I have marked the lateral height. So see how it's not really, the height of the shape itself doesn't really help us in this case. We may need it to find L, but we're going to start off with kind of an easy one. All right, so the surface area, if this is my base B, I'll go ahead and kind of make him B here. All right, there's my base, and these are the triangles, the lateral faces around the outside of B. So we would say in order to find the surface area of a pyramid, we need to find the area of the base. Now they use that big capital B again. It's not always going to be a triangle, so they don't put a formula in there. It might be a square, it might be a hexagon or a pentagon. So we just say, all right, this is the area of the base. All right, so they use the big old B. And then we're going to add to it the lateral faces, all right? So again, what we want to say is, all right, if we have a triangle, then we know that we're going to have 3 triangles that we add to here. You know, our base is a triangle. If it's a square, then we would have 4 times our triangle, right? So we talked about it, finding the lateral face, that the height of our triangle is that L, and the length of the side of the base is going to be the base of my triangle. So we're going to say this is going to be 3 times 1/2 base times my height, but we're going to go ahead and use that L in this case. So that we get the correct height there. All right, when we make this, let's see, we'll pull up our square pyramid, then the formula changes to be 4 triangles, right? So this would change here. So this is really kind of the number of sides is what we want. Number of sides times the area of 1 triangle. Now let's see how the book puts that together. All right, I wanted to do a little bit of erasing to kind of be able to put our formula down here. But let's look at our net again. We have the surface area is the area of base plus the number of triangles times the area of 1 triangle, 1/2 base times slant height, there, L. In the book, similar to what they did with the last section, they said, well, if we have the number of triangles and the length of the base, since they're all the same, the length of the base, and we have 3 triangles, that's actually going to be the perimeter of my base as well, base plus base plus base. So they go ahead and combine these two so that they say the surface area is the area of the base B plus 1/2, combining that to perimeter, capital P times L. And that's what the formula looks like. You can again use the formula. Makes sense to you? That's fine. If not, then go ahead and find each triangle separately, add them together or times how many there are, and find the base separately, okay? Don't care which one you do. But this is the way the formula looks in the book. Surface area of a pyramid, area of the base plus 1/2 times the perimeter times the slant height. Okay, let's figure out a pyramid from scratch. I do not have an octagonal or octagonal, not quite sure how you say that, octagonal pyramid. I tried to draw one here, comes out a little funny, but hopefully you see it when we open it up. We have the base is an octagon, a regular octagon, and all the triangles open up kind of like a star, like I said. Once you get more sides there, it looks more like a star. And we're going to try to find the surface area. So we're going to do it both ways. First of all, breaking it down. Secondly, looking at the formula and see which way you guys like to do it. All right. So we're fortunate that they give us all the right parts this time. We don't have to do a whole lot of extra work, but there's enough work in it by itself. So for an octagonal pyramid, they said we have the octagon has sides of base 13. We have the lateral height of 18. Let's kind of look at it here. That's the length from the vertex down to the side. That's my lateral height. The side length was 13. Lateral was 18. And they actually even give us the apothem because we have an octagon down here, and we have to use what, if you guys remember from chapter 11, how to find the area of a regular polygon. We have the octagon, so they even give us the apothem, which is really nice. So they give us all the parts for it. So let's start with, either way, we're going to have to find the area of the base. So let's go ahead and get that one over with first. We have an octagon here. So if you remember, the area of a polygon was 1/2 AP, where P is the perimeter and A is our apothem. And that one, if you use the formula, that took care of taking care of how many triangles you have, because the perimeter of the octagon takes that into consideration. So if you don't use the formula, then it's 1/2 base times height, where my height is my slant height, and then times the number of triangles. So let's work this one out. So they gave us the apothem is 15.9, and the perimeter, because there are 8 triangles, then the base is 13, so it's going to be 8 times 13. All right, to get our perimeter. Let's go ahead and multiply all that across, find the area of our base. We have 8 times 13 times 15.9, and go ahead and divide that by 2. We have 826.8 units squared, and we're going to call that our big B, because that's the part that we use it for in our formula. I know I said area up here, but in our formula for the surface area, they use B. All right, that's one part. We're like partway done. So the next thing is we find the area of one of the triangles. So here we go, area of our triangle. We're using, if you remember, 1/2 base times height, but our height is L, so we say 1/2 base times the slant height. And the base, they told us, of one of the triangles is 13 all the way around. So 1/2 times 13 times the slant height of 18 winds up being 13 times 18 divided by 2 is 117. Now, since we're doing these separately, then we take this and say, all right, we have 8 triangles. So the last step is let's multiply that by 8, because we have 8 triangles. And our lateral faces are all 936 units squared. So my surface area is the area of the base plus the lateral faces, which are all the triangles. So we have 826.8 plus 936 equals, going to add that together, 1,762.8. Okay, that's the total. Now we're going to kind of check it with our formula and see if everything still works out the same. All right, so in the book, the formula for surface area is the area of the base B plus 1/2 times the perimeter times the slant height. So from here you kind of put everything in it. You kind of have to already figure that part out. So we already know it's 826.8, and then plus 1/2 perimeter, 13 times 8. Did we figure that one out earlier? I don't think so. 104 times my slant height of 18. And it should all equal the same thing. 104 times 18 divided by 2, 936, boom. So we do wind up with 826.8 plus 936 is 1762.8. Now you might say, oh, that was a lot faster, but kind of because we already worked some of it out. You still had to work out the B separately. So it may be faster, but give it a try. I like doing it this way again, then I'm not memorizing formulas. I'm looking at what the shape looks like, figure out each part and add it together, okay? All right, let's start looking at our cone. All right, let's pause for our first question. Please tell me, what does the net of a pyramid look like? All right, let's look at a cone. Those are the parts that we're going to need in order to find the surface area of a cone. The part that makes it more difficult is that there's no triangles. So we have to figure out what kind of shape is that lateral face. It still has that name, the lateral face is the nice smooth area around the cone. If you look at my 3-dimensional one here that I made, this here. We're going to open it up and you're going to see what kind of shape it actually is once you open it, but it's not a triangle, okay? So, but the parts we need, the bottom is a circle always, so we are going to have to be given the radius so we can find the area of our circle, but believe it or not, we're going to use that in helping us to find the lateral face as well. Similarly, we do have L, again, the slant height, and it is the distance from my vertex down the side to the edge of the circle. That's my slant height, different as you can see from the height of the cone. Now we're dealing just with right cones, meaning that the vertex at the top here is always going to be directly over the center of my circle. They do have some that are not a right cone. They would call an oblique cone. Like if we put the vertex up here, we could still have a cone. It would just be kind of angled different. But again, that throws off the shape of the lateral face. So we're not going to be doing these guys. We're just going to stick with our right cones for now. Okay? So let's go ahead and start by opening up my cone so you can see the map, and then we'll just put it up here on the board too. So obviously the top comes off. We have the circle, the base out here. I'm going to go ahead and open up along the side here. Hopefully just get the tape and not the paper. Okay. Now, this one you're most likely going to use the formula just because it's much easier. And if you look at what our map looks like, it's actually a sector of a circle that we're dealing with, the lateral face. But it gets a little confusing. We're going to look at where the formula comes from, but it's going to be easier to follow the formula, okay? So it's similar to the other one. We do have the area of the base, so we're going to have the surface area, find the area of our circle, and then finding the area of this sector. Now, fortunately, we actually looked at finding the areas of sectors last chapter, so we're going to use that in order to derive our formula, okay? So let me erase this and let's kind of take a look at this. All right, let's see if we can figure out how we derive this formula, okay? Now hang in there, it takes a little bit of thinking. Hopefully it's not too much, but I'm not going to expect you to derive it, but I just kind of want you to see where it comes from, because it's kind of cool. All right, so the surface area of my cone, we do start the same. We say, all right, we need the area of that base, but of course the base is a circle, so they go ahead and say, all right, I know that's going to be pi r squared using the radius. Notice the radius is over here, not over here, of that circle. So that's the area of the base. But now here's the interesting part. We're going to try to figure out how to find the lateral area. All right. Now if you use your imagination, you can see that both of these lines are the slant height, because that's where I cut it, right? It just opens up into that sector. The first thing I want to point out, though, if you notice, can you see how the arc, and I guess I'm going to go ahead and just redraw this. Let me use a different color, though. We'll use pink. Can you see that this is actually a sector, and this is going to be a kind of a bad sketch, but it's a sector of a circle whose radius is L, okay? Hopefully that kind of puts it in perspective a little bit. This is actually an arc of the same circle that binds this sector, all right? So if we had points A and B here, we could say that that's arc AB. Now arc AB actually is the part that goes around the base. So if I put my cone back together, this arc goes completely around my base. So I can actually find the length of this arc right here is the circumference. See, I'll say the length of arc AB equals the circumference of the base using that R. All right, so that is the length of the arc there. Now that's going to help us find the area. Okay, so the sector is a section of the circle, just like this arc is the section of the circumference. And if you remember when we were figuring out circumference or lengths of arcs and areas of sectors, we used the fact that the measure of the arc over 360 gave us the fraction that it was part of. So the circumference, that arc was that fraction of the circumference, and this area was that fraction of the whole area. And that means that we can set up a ratio. So actually, because of the measure of the arc, let's go ahead and use AB, measure of AB over 360 is equal to the arc length. So we'll say the length of AB over the circumference of this circle, which would be 2 pi L, because my radius of this circle is L. 2 pi instead of 2 pi R, 2 pi L, because my radius is L. And but that also equals the area of the sector, because it's the same fraction. The area of sector, we'll just do that way, the area of the sector over the area of the whole circle. And the area of the circle we know is pi, not R, but pi L squared. Okay? So since they all equal the same fraction, we could set these two equal. Alright? Now we're going to do a little bit of algebra because we're looking actually just for the area of the sector. So that means I'm going to multiply or move this to this other side over here. Now let me erase some stuff and we'll transfer that up there and keep going. Okay, I decided to use the second board over top so I can reference my picture again as I need to in a second. Alright, so we said this, I just rewrote what we had over there. The length of AB of that arc AB over the circumference of the circle equals the area of the sector created by that arc over the area of the whole circle. So I said we're trying to find the area of the sector, so I'm going to go ahead and move him to the other side by multiplying both sides times pi L squared. So I wind up, let me shift this, the area of the sector equals the length of AB, arc AB, over 2 pi L times pi L squared. Now it's kind of over 1, so it keeps it on the top there. Now the one thing we didn't talk about, if you remember, we said the length of arc AB, because that is the part that goes around my circle, is actually the circumference of my base. So I'm going to go ahead and substitute that in there. I know the length of AB is 2 pi R, because I know the radius, over 2 pi L times pi L squared. Now we get to do some canceling, which is why algebra can be fun. Get rid of some of all this ugliness, get rid of the 2's and the pi's there. Technically, let's go ahead and write it together, but we'll see one more thing we can do. On the top we have R times pi times L squared. So I'm going to go pi R L squared. And what's left on the bottom is a little lonely L. So we can cancel. We've got 2 up top and 1 on the bottom. You can cancel it. So the area of our sector is actually just pi R L. It reduces nicely. And that is the part that is we're going to put back into our formula. Okay, that's why I didn't want to get rid of it. So our surface area is the area of the base plus the area of the sector. And we know that the area of the base was pi R squared. The area of our sector is now pi R L. And we have to leave them both there because they're being added. Let's see if I can get rid of some of this. And you can't like do any canceling or multiplying if nothing's squared anymore except this guy. Let me rewrite that so we can see it and we'll use it one time. Let me go ahead and kind of circle this for you if you're taking notes. So here's the area of the surface area of a cone. And let's do an example. Okay, ready for question 2? Tell me where is the slant height of a cone? Okay, we are ready to do a problem finding the surface area of a cone. Actually, they ask us to do 2 parts. They say in this problem find the lateral face and the surface area. Now in order to find the surface area you do have to find that lateral face, so it's really kind of just giving us a step at a time to get to the end. But this is good, we'll break it apart and look at it. So we're going to have 2 things. First we're going to look at the lateral face. Now that's what we just derived. That was the equation we were doing. The lateral face is the area, the nice smooth area around the outside of the cone, which is the area of the sector, which we just solved for. So the lateral face is equal to pi R L. That's the part we just solved for. So if you have the radius and the lateral face, the radius and the slant height, then we can find the lateral face. But of course, they just gave us, in this cone, we know the height of the cone is 13, and the radius of the base is 5.5. So we have to find, and they're going to make you do this a lot, you have to find that lateral, that slant height there. So again, this is nice that they give us a nice little right triangle. The radius goes to the center drops to the vertex, and we get a nice little right triangle. So let's go ahead and use our Pythagorean theorem. This is my hypotenuse, so I know L squared equals 13 squared plus 5.5 squared. Let's go ahead and work this one out. We get 13 squared plus, I'm going to put it over here, 5.5 squared is 199.25. So when I take the square root of both sides, L is going to be 14.1. There's my lateral, or my slant height, 14.1. Now I can find the lateral face, because it's pi times my radius, which is the radius of the base, 5.5 times L, which is that slant height, 14.1. We're going to go ahead and get a number, not leaving pi in there this time. So we have 5.5 times 14.1. I'm going to go ahead and use 3.14 just to be quick. And we have 243.5 units squared. Now that's my lateral face, right? So let's write out our formula for surface area. I'm going to do it in orange so you can kind of see what we're doing. If you remember it from just a minute ago, surface area of a cone is the area of the base plus the lateral face. So they kind of had us figure out the part of the formula already. The area of the base is always going to be a circle for a cone, so it's pi r squared plus pi rl. That is my formula. All right, so we already know this. We can transfer that over. I'm going to go ahead and fill it all out so you can see it as if we didn't do the lateral face. But you can just find the area of the base and add what we already figured out. All right, let me switch back to green. So we have, using our formula, it's pi times my radius 5.5 squared plus pi times my radius again 5.5 times my slant height, which we found 14.1, and we go ahead and multiply it all out. And actually I could leave the pi in there, see what happens with that. So we get 5.5 times 5.5, which is 30.25 pi plus 5.5 times 14.1 is 77.55 pi. We can go ahead and add this 77.55 plus 30.25, and that gives us 107.8 pi. And then if they ask you to figure it all the way out, go ahead, multiply times 3.14, and it's 338.49, that's 8.5. All right, so you'll see this is pretty straightforward. You're not breaking down into circles, you're not break it down into parts and finding triangles and adding all the faces. It's just going to be a formula, okay? So the parts that you need, you have to have the radius, you have to have the slant height in order to find it. But if you have those two things, you just plug it into the formula, okay? So a lot of times they will have you find that slant height. They're going to give you the height of the figure, so don't let that throw you off and think, oh, the height is L. It has to be the slant height, okay? So give those a try. I know they're kind of long. Hopefully you won't find them to be too tedious, but work on it, kind of get it in your head. I have decided for the exam, we are going to let you guys have a formula sheet, so you will have that handy, but you have to know how to use it, okay? So go ahead and practice these, and we will touch base tomorrow, and the next day will just be more review. So if you have any more questions before our quiz on Friday. So hopefully you guys have a good time. We're going to do our joke of the day. Give me 1 second.